everyone. Welcome back to my math teaching channel online. In this video, I will continue with the previous lesson about the derivative, find the derivative using the first fundamental concept in calculus, which is the same like to find the slope of a tangent line at a specific point. Let's connect back to the real life problem. We know that, let's say your function is the function of your driving on the road. And we know that our speed changing, sometimes we accelerate up and sometimes we decelerate down. So your curve, your function no longer to be a linear, like a constant speed when you learn in Math 9, Math 10, linear function, but your function of driving now is a curve, up and down, right? And the derivative help you to define the instantaneous velocity at a specific time as when your function is a driving function. So you want to find the speed or the velocity of your car at 9 a.m. or maybe at 10 a.m. or maybe at 1 p.m. And the time is when we draw it on the graph, represented by the x-coordinate, right? And your driving, your speed, your driving, the y function is just the y-coordinate at particular point. So you want to find the instantaneous velocity speed at a certain point on the graph, as one time on the graph, right? At 10 p.m. or 1 p.m. Okay, so now that is the reconnection between this lesson to previous lesson we learned, right? Now let's get into a question right away. Now this type of question is one of typical question in the calculus course. Apply the derivative idea, right? So let's look at the question. Find an equation of a tangent line to the curve or to the graph at the point x is 4 and y coordinate is 5. And this is the function they give it to you, right? This is the whole thing. This is the whole function f of x. So again, we're going to using a first fundamental concept in calculus, which is the derivative f prime x will be equal the slope represented by m, right? The same like the slope of the linear, and that is the same as you want to find the limit when h approach to 0 of the function f x plus h minus f of x, all of this over h. Okay, so in the future, when you learn the rules of the derivative, we will not have to find out the slope using the long way like this. But like any other course, if you want to learn accounting, you have to have a basic of bookkeeping before you can use the software and do the shortcut. Any other topic, any other subject, right? So that's why we use the first fundamental concept in derivative of calculus, okay? So we'll find using this formula. Now, in the previous lesson, I showed you how to substitute this function into here and simplify it and cancel out. But in this question, we get into a point that we're going to apply, given the point here, we want to find the derivative of this function at this point, which is the same like the slope of your tangent line to the point P on the curve at the specific time. Now, there are two ways of doing it. We can do like the previous lesson I showed you. But a second way is shorter and easier. If you already know the x-coordinate, because the tangent line, right? If your curve like this and you want to find the equation of this tangent line, touch the curve at point P here, right? Which is point P here turned out to be 4 and 5, right? Then you already know the x-coordinate and the y-coordinate of point P, so we can substitute right into the function. But before we do that, let's do something like this. Limit h approach to 0. Let's substitute this function into here first, right? So you will have any x here will replace by x plus h. So you have x plus h adding with 4 over x plus h. And then minus with your f of x. And your f of x is x. This is the function f of x, right? F of x equal the whole thing here. X plus 4 over x. All of this over h. And that will be equal limit when h approach to 0. And you want to substitute the coordinate 4 and 5 right into this numerator. So x will become 4 plus h. Adding with 4, just follow the expression here. Down here will be 4 plus h. Minus. Now you know this is the function f of x. And we substitute the x by the coordinate 4. So we can do the same by substitute this f of x is the y value here, because this is a function of y and this is the y value. So we can substitute the whole thing here by 5. And if you found it wired like that, it's weird, and you don't believe me, you can just substitute this by 4, adding with 4 divided by 4, and you calculate it, you will get this value is the same like 20 over 4. And 20 over 4 equals 5. So this, if you substitute, no problem. It's just longer, you have to do it, right? But I know that this value is just the value of 5, so I write it right here, right? If you put 4 in here, 4 over 1, you have to do common denominator, which is this is 4 times 4 is 16, add 4 20, divided by 4 equals 5. So exactly, this is the y coordinate, this is the y function, f of x. And this is the coordinate. When we substitute the 4 in here, we calculate, we get the value of y is 5. So that's just the way it is, okay? All of this we divide by h. And we want to find when h approaches to 0, what happened to this? So let me adjust the computer to see if you can see the rest of it. So I'm going to simplify down here a little bit, okay? Now you can see this is a very complicated function, right? We have here and then a chunk of a fraction and subtract a whole number, all of that over another number, right? So let's doing a little bit of simplification. Now, if I put 1 underneath here, this is adding fraction, and we want to find the common denominator, right? It means at this bottom, we have to time with this to get a common denominator. So in step 1, I have to time with this bracket. And on the top, I have to do the same. So this bracket is like 4 plus h times with 4 plus h to get the common denominator, right? So this will become 4 plus h times 4 plus h is 4 plus h on of this square. You can put it like that as well. Adding with 4 and on of this over the same common denominator. Once you make common denominator already, you can join them in the same common denominator, right? Underneath like that. Minus with 5. Now this 5 is over 1, right? And you need to have another common denominator for this number as well. So that will time with 4 plus h. And of course, down here, you time with 4 plus h, right? So now you have a same common denominator, but don't forget, you still have to divide this by h, right? So now let's simplify again. So now you have a fraction like this with the same common denominator. You can join them in one fraction. The top will be the same expression here, right? From here to here. And down here, just one common denominator. So that will become 4 plus h on of this square plus 4 minus 5 times 4. Let me multiply through, right? So minus 5 times 4 is minus 20. And minus 5 times h is minus 5h. On of this will be over 4 plus h, one common denominator. And now you want to bring this h up here as well. You're allowed to do that because you divide twice, right? So you bring it h up here. So that's look a little bit cleaner. All right. So let's continue to the next board. So this bracket, remember I told you if you learn quadratic function, you know a plus b will be equal to a squared plus 2 times a times b plus b squared. This formula always keep in your mind. That's a very useful formula for you to expand this bracket a lot quicker than you multiply two brackets with the same number together. So let's use this formula right now to expand this one. So this is limit of h to 0. And here you will have apply this, right? 4, which is a square here, which is 16, for 4 times 4 is 16, plus 2 times a times b. This is your a, this is your b, right? So this bracket, okay, see this? Right? So I just use this up here. Now, if I show you this, you won't see it. You know what? What I'm going to do is to make sure you don't miss anything, I'm going to rewrite, copy this fraction here, okay? So bear with me a second. Let me copy it because it's hard to move backward and forward. So let me put that from down here up here, so it's not cutting you anything. And this will be 4 plus h on of this square plus 4 minus 20 minus 5h on of this over h time with 4 plus h. Okay, so I copied this part down here up here. Let's see if you can see it. Yeah. Okay. So now I'm going to expand this bracket. And when I expand this bracket, I use the formula of a plus b on of the square equal a square plus 2 times a times b plus b square. So 4, this is 4, and this is h. Your a and b is 4 plus h, right? On of them square. Follow this right-hand side. You have 4 times 4, which is 4 square, which is 16. So that's 16. Plus 2 times a times b, 2 times 4 is 8, ah, right? Your b is 8. So ah, 8h plus b square, which is this h squared, plus with 4, minus 20 minus 5 times h, all of this under h 4 plus h. Okay, so that's how we go so far. Now let's simplify this a little bit more. So if I add the 16 here with the 4 here, what do I get? I get 20. And 20 minus 20, they gone, right? They become 0. 8h minus 5h is 3h, right? 8 minus 5 is 3h. So this gone because we take care of that already. 8 minus 5 is 3h plus h squared. All of this over h, 4 plus h. So now this become limit when h approach to 0. Let's factor this out a little bit. So the common factor for this is h, so we put down h, times 3 plus another h over h times 4 plus h. Okay, so at this point, when I factor, and again, I told you, if you forget about the concept of factor out the algebra, just go back to my Math 10 general common factor, watch that video, you will understand how I factor this, right? So now let's cancel the h with the h down here. So now you have limit of h to the power 0. Now we're allowed to substitute the h by 0 into the fraction without worrying we blow up this bottom, become 0, right? So here you see the slope of your tangent line is equal to 3 over 4. This is equal the slope of the tangent line, right? And remember, your function of driving sometimes up and down. And at this point, right, you want to find the equation of this tangent line, right? Now we know the slope of this point already is 3 over 4, right? But now we have to, they ask us to find an equation of your tangent line. So you're going to find the equation for this tangent. Now this tangent is not a curve, it's a linear, right? And any equation of linear, if recall your stuff memorized, you have two forms of it, which is y equal mx plus b, or y equal, or another form, which is slope point form, which is y minus y0 equal m times x minus x0. Now, if we want to write the equation of our tangent line using the second one is a lot easier, right? Because what it is, we have a point right there already, 4 and 5. So we can, the point here, y0 represent for our point, which is x is 4. Oh, sorry, y is 5, and x here, x0 here, just 4. So that's the way we find the equation of any linear, right? We want to find the equation of our tangent. Remember, we want to find the equation of the linear line because our tangent is a linear line. So we use the form of linear equation in here. It's nothing to do with the curve, right? The curve is this function, okay? So now we will put in the form y minus y0 is 5 equal m is the slope we find here, right? We just find it 3 over 4 time with x is just any x coordinate on your function minus x0 here is 4. Now at this point you're done with the equation of your tangent line. That is the answer. But if you want to be clean cut a little bit, we can simplify this. So this becomes y minus 5 equal, distributing here, you have 3 over 4x minus, cancel the 4 with the 4 down here, and multiply the 3, or you can multiply 3 times 4, 12 divided by 4, right, is 3. So now simplify further, you're going to move the 5, kick the 5 over. So you have 3 over 4x minus 3 minus 5 become plus 5 when you pick this number over. So your equation now will become y equal, you see the board? Yeah, I have no room. So y will be equal 3 over 4x minus 3 plus 5 equal plus 2. So that is the answer of this question. So I went through with you the one typical question in the calculus course. Of course, I will upload the exercise for you to do this kind of a question, right? But I hope that throughout my previous video, connecting with this video, you understood now what is a calculus and what is a derivative, right? And why do we have to use it? Because the function of your driving up and down slope, increasing, decreasing, not a constant speed. And in the constant speed, we're talking about the linear function. When your speed is just 80 kilometer an hour or 100 kilometer an hour, but in real life, we want to find your specific speed at a specific point in time. And our function no longer the linear like this, but it might be the wavy curve like this or the curve like this. And using the derivative concept, the limit, which I explained in the first lesson, right? The fundamental concept of the first lesson in calculus about derivative, which is really derived from this formula, right? We form it, become this formula, limit of f of x plus h minus fx divided by h. So now on what we do is following our formula and figure it out. Our instantaneous velocity speed, which is the rate of change of the measurement of your tangent line to a particular point. And we find out the slope, the rate of change of our driving a car, for example, is 3 over 4, right? And now the question asks you to find an equation of a tangent line. So now you will apply the linear concept because your tangent line, right, is a linear, and this is the equation of h, which is you find out here, 3 over 4x plus 2, right? Your linear and your equation like this is the equation of your tangent line, okay? Touching at the point 4 for x and 5 for y. All right, so I hope that the whole video and my explanation to you sound clearer each time we apply one problem. If you register into my online course, the website thinkific.com with my name, T. Nancy Pham. Now, in the future, when I am developing the course longer and longer, get more video to you, I will give you a URL so you can get into the website and register my course online. The benefit, if you learn from my course, because I don't teach this concept and then jump another concept. I develop my course, follow the whole course. This is the whole calculus course. And one video after another is a sequence of video of lesson 1, lesson 2, and chapter 1, chapter 3, so on. By learning that way, you will have a home picture. and you will understand much better, right? Because as I said, mathematics is sequence of steps. It builds from step 1, step 2, hierarchical. And therefore, you see, any of the concept of this will relate it with previous lesson, which is the linear, the constant speed, and now you have a curve, right? Driving a car up and down the hill, and you have to derive the calculus concept to find your particular speed at particular time. Anyway, I will end the video in here, and I hope that you enjoy my video and give me a thumb if you like it, and support and cheer up my spirit with your like button. Now I am developing the free education online to everyone. So I think that is nothing wrong with that. And if you, you know, like appreciate my teaching online free education to everybody, we share the knowledge and we learn it from each other. And if you think that is nothing wrong, I know that is nothing wrong, because what I do is spend my time to teach you the mathematics subject, which is a top subject, and most of you don't like it, right? I don't know, it's just my assumption. So if you need my help, the support right there for you, then I wish you can support me as well by hit the thumb and like button. So thank you very much for watching. Bye for now, and stay tuned for the next video, which is a lot more interesting. We'll get into solving problem using derivative. But before you see the word problem applied to real life to solve using derivative, you have to learn the rules of derivative as well. And so the next lesson will get into the rules of the derivative. And we will use that rule to calculate the limit or calculate the slope of our tangent line in an easier way. So hope you enjoy. Bye for now.